All right, hi, this is your video for solving radical equations. Real quickly though, an announcement, you have a test coming up next week on Thursday or Friday, depending on your class day, and that's the third test for the quarter. If you end up needing to retake that test, if you're a Friday student, since that's the last day of the quarter, we'll give you till the weekend to do the retake because our grades are due by like Monday or Tuesday. So just know that there will be a retake opportunity, but it'll be more rushed than it normally is. And then by next Friday, you have any late work from Unit 3 is due. And if you need to retake Test 2 or take Test 2, that's also due by next Friday. So today's lesson is on solving equations that have radicals in them. The last two lessons were rational equations, which had fractions with variables in the denominators. Today's equations are going to have radicals in them and not just square roots. This is really the important part of the lesson, or the notes that I want you to take down before we do the practice problems. So take a few minutes, pause this video, write these steps down if you're taking your own notes, and then come back to the video when you're ready. If you have the notes printed, please notice all of these things I redacted that I took off, because I'm cutting out some of the longer problems just because it's 2020 and we're kind of trying to save some time since we have less time. So this black stuff is stuff that applied to the harder problems that I cut out. So take a moment and write these down if you're writing your own notes, and pause your video. And if you have the notes printed, I did add something on step 5. Check for extraneous roots when applying an even power in step 2. All right, so we're only going to be doing 2 of these practice problems. We're cutting out the third one. And so here's what we have going on. We've got this equation. It has a radical, and step 1 said to isolate the radical term. So let's just be sure we know which piece that means. It means this. We need to get this radical piece all by itself. But right now, it has a division by 4 attached to it on its outside, and it has a -5 on its outside. And so we have to undo those things. This is the same process as if we had, like, instead of a radical where I highlighted in that spot, if we had just a regular variable, x, and we were trying to solve for it, we would add 5 to both sides first, and then we would multiply by the 4. And that's how we would get x all by itself and solve for it. Those are the same steps we're going to do with this radical term. It's just that once we isolate the radical term, there will be more math to do than if it was a simple equation like this one. So let's get started on that process. Subscribe below, comment below. Not really, that was a joke. I was just feeling like I was sounding like a YouTuber. Okay, so step 1, add 5 to both sides. That will give me cube root of 6x minus 7, still over 4, equals -1. And then to undo the divide by 4, I multiply by 4, inverse operation. And the 4's cancel on the left, leaving me just the cube root of 6x minus 7 equals -4. So that means my radical term is isolated. It's all alone. There's nothing else happening to it on the outside of the radical. So it's isolated. And now step 2 is to apply the power needed to cancel out the root. Well, the root is a third root. And so the power needed to cancel that out is a power of 3. Just like squaring cancels out a square root, cubing cancels out a cube root. And because it's an equation, you can't just do it to the left side. You have to also do it to the right side. It keeps it in balance. So then what we have left on the left side is just what's inside the radical, the 6x minus 7. That's called the radicand, not the radicand. And then on, I wrote cube or square right here. This is cube. And let's real quick touch base on what -4 to the third power means. It means -4 times itself. So the first two give me -16. And then when I multiply it by the third -4, I have positive 64. Step 3 on your notes does not apply. We're actually not doing that. It's for when there's more than one radical in your original problem, but we're skipping those in 2020. So step 4 then is to solve your equation. So you solve yours, I'll solve mine. Sorry, this was a -64. I don't even know you guys. Give me just a minute. Did you even see my mistake here? It's because it's before school and I'm trying to rush through this and I haven't had my second cup of coffee. That's it. I'm blaming my second cup of coffee. You can't use that on a test. Like, don't ever come to tutoring and say, I didn't have my second cup of coffee, miss. Can I have my points back? I'll be like, oh, I feel that, but no. So -64 plus 7 is a -56. And then from here, you divide by 6. And this gives you -57/6 on the right. And that you can actually simplify. 3 will divide out of both of those integers. And a quick mental tip. So if you're ever trying to figure out a number to simplify a fraction by, if you were trying 3 on this, you know that 3 goes into 6. That's easy. But the 57 on top in the numerator, if you add the units, or I'm sorry, the digits, like 5 plus 7 is 12. And since 12 is divisible by 3, 57 is also divisible by 3. That goes for any number. So that will give me -/2. And step 5, if you go look at your step 5, it says to check for extraneous roots. Now, usually when we have an extra step that says to check, we just kind of are like, not so much. I'm just going to wing it. I'm just going to get what I get. Pretty sure I'm good. Move on to the next problem. But this isn't a blow off, check your work step. This is actually, you need to do this because what happens is sometimes when you're solving radical equations, your process introduces an extraneous root, an extraneous solution. That means it won't actually check out and work in the original problem. Now, I will give you this. I'm only requiring you to check extraneous solutions in radical equations when you've used an even power in step 2. And if you're curious as to why, if you go look at the PDF notes in your Google Classroom, I have an example that shows why you have to be careful only with even powers. But I'm not going to explain that in the video just for the sake of time. So in this problem in step 2, we raised both sides to an odd power. So I'm not going to require you to check for extraneous. So step 5 on this one is not required because the power in step 2 was odd. Only going to require you to do it for even powers. So we can go ahead and stop here. Okay, pretty sure x equals -19. All right. So pause the video if you're still writing that down, because I'm about to skip. All right, so here's the next one. Pause the video, write this down if you're taking your own notes and you don't have them printed. So the first step, just like the last problem, was to get the radical term all by itself. Right now, what's on the outside of it is a plus x, okay? So to get rid of that plus x, we just do the opposite to both sides. And boom, it's already isolated, okay? Now, step 2 is to raise both sides to whatever power you need to get rid of the radical, right? To undo the radical. And you might be looking at the radical and thinking, oh, there's no number on the radical. Like the last one had a 3 for cube root. So how do I know what number goes here? Well, remember that square root is so common of a root that we don't write the number because we just want to cut out writing, you know. So it's an understood 2 for the root when there's no number written. And so in order to undo that root, we want to raise both sides to the power of 2. And this is where you should be thinking, oh, okay, I'm going to have to check for extraneous roots in the last step because 2 is an even power, right? So if you were solving a problem with a 4th root and you raised both sides to the 4th power, that's even, and I would be asking you to check for extraneous at the end. But for now, we're not there yet, so let's finish this step. So on the left-hand side, the power cancels out the root, leaving the radicand of 2x plus 31. And on the right-hand side, we have 2 minus x squared. Let me tell you a bad math alert. Are you ready? Bad math alert. The answer to 2 minus x quantity or parentheses squared is not minus x squared. It's a bad math alert, okay? Yes, there will be a 4 in the answer, and yes, there will be an x squared in the answer. Or it's not this either, 4 plus x squared. Remember that 2 minus x quantity squared means 2 minus x times 2 minus x. And that is a FOIL or double distributive property. And so you're missing some terms on the, you did the bad math, you're missing some terms. So watch what happens on that right-hand side. I distribute this first 2, and I get 4 minus 2x. Then I distribute this negative x through. I get negative 2x and then positive x squared. So you see there's some whole other terms going on there that the bad math alert didn't cover. So on the right-hand side, I really have 4 minus 4x plus x squared. And on the left, I have 2x. Step 3 does not apply. It's been redacted. Your steps were heavily redacted to protect, you know, the steps. So step 4 is to solve. So that's what we're going to do. Here's some clues. If you're looking at this problem right now and you're like, I don't even know what exactly I'm supposed to be doing next. Here are your clues. There's an x squared term. So chances are really good you're going to have to be factoring at some point. And in order to factor, you have to get the equation equal to 0 and put stuff in standard form. So you see the x squared term, you're going to probably try factoring, which means you need to get it equal to 0. And so since the x squared on the right-hand side is already positive, I'm going to take the stuff on the left and move it over to the right, because I want to keep the x squared positive. So I will subtract 2x and subtract 31 from both sides. And when I write it on the right-hand side, I'm going to line it up with my like terms so that they are matchy-matchy. So on the left, I have 0. And on the right, I'm going to go ahead and write it in standard form as I'm combining like terms. So that would give me x squared minus 6x minus 27. Now I'm going to do swing method here. But even if you do grouping, it starts out the same way. What multiplies to AC and adds to B? So A times C, the A is 1. And C is negative 27. So 1 times negative 27 is negative 27. And B is negative 6. And what multiplies to negative 27 and adds to negative 6, negative 9 and 3. And for swing method, you always want to divide by your A value here. When A is 1, though, it doesn't actually change your value. And then to make factors with the negative 9 and the 3, you attach variables to them. So x minus 9, x. If you like grouping, your next step would have started out like this. it would have started out as x squared minus 9x plus 3x minus 27. And then you would have continued on with your grouping and ended up where we are at x minus 9, x plus 3. And so this is factored form, right? Factors are things that are being multiplied. So we have this grouping x minus 9, one factor, times another grouping x plus 3, the second factor. So this is factored form. And when factors are multiplied like this and equals 0 like that, that means one or both is equal to 0. So we break it up instead of and solve them. So I get x equals 9 and x equals negative 3. And even though it really feels like we want to be done, because we raised to an even power in step 2, we need to check that these solutions work in the original problem. Do not plug them into any of those middle math steps, okay? You want to plug it into the original equation to check them out. So let's do that. I'll switch colors so we see if it's a new process. So here's the original. So this is step 2x plus 31 plus x. So let's check x equals 9 by plugging it in everywhere you see an x. Now, when we're plugging in to check stuff, we're no longer solving. We are just using order of operations to simplify everything and see if we end up with a true statement or a false statement, okay? So I plugged in 9 wherever the x's are, and I'm still going to be simplifying inside the radical. A radical works like parentheses in PEMDAS. Okay, it's a grouping symbol. So you have to do the math inside there before other math. So inside there I have 2 times 9, which is 18, plus 31, and 18 plus 31 is 49. And when I square root 49 here, I only need the positive version. This is called the principal square root. And it's what you only need the positive version when your original problem already had a square root in it. Whenever we do plus or minus, it's because we introduced the square root. Like, see this problem, x squared equals 9. If I was solving that, I would have to introduce myself into the problem, a square root on both sides. And in that case, we do want both the positive and negative solution because it would work in the original problem, which did not have a square root. Remember? You remember. But in this example, with from our problem, the square root was already in the original problem. And so when we go to take the square root of 49, we just need the positive version, the principal or main square root. And so that gives me 7 plus 9 equals 2, which is absolutely not true, okay? So we know that x equals 9 is extraneous when that happens. So let's check out our other solution of x equals negative 3. So I plug it in for all the x's that live in Texas. And then plus x is plus negative 3, which is just minus 3. And then inside the radical, that gives me negative 6 plus 31, which gives me 25, which gives me 5. And then I bring down this other stuff, minus 3 equals 2. And is it true that 5 minus 3 equals 2? Absolutely. So what that means for my final answer is this. X equals negative 3 is a solution. X equals 9 is extraneous. Hold on, I have to fix my writing. X equals 9 is extraneous. All right. And we are skipping the last problem on your notes because hashtag 2020. If you look at your homework for this section, your practice problems, I have solutions to all of them, but the ones that we're omitting this year, it says omit 2020 in the corner of those problems. So you'll know which problems to avoid. And the grade for today is to submit a picture of these completed notes into your Google Classroom. And I hope you have a wonderful weekend.